Hello everyone. Continuing the Learn with Me series on the JMeter topic. Today we'll be covering some other topics of JMeters. Let's go through the timer topics. Timers. Since version 3.1, a new feature in beta module is of JMeter 3.1 and subject to changes has been implemented, which provides the following feature. You can apply a multiplication factor on the sleep thread delays computed by random timer by setting property timer.factor equals to float number, where float number is decimal positive number. JMeter will multiply this factor by computed sleep delay. This feature can be used by Gaussian random timer, Poisson random timer, and uniform random timer. Note that timers are processed before each sampler in the scope, okay, in which they are found. Timers are, this is the statement that we need to keep in mind. Note that timers are processed before each sampler in the scope in which they are found. If there are several timers in the same scope, all the timers will be processed before each sampler. Alright. Timers are only processed in conjunction with a sampler. A timer which is not in the same scope as a sampler will not be processed at all. A timer which is not in the same scope as a sampler will not be processed at all. To apply a timer to a single sampler, add a timer as a child element of the sampler. The timer will be applied before sampler is executed. To apply a timer after a sampler, either add it to the next sampler. To apply a timer after a sampler, either add it to the next sampler, okay, or it as a child of a flow control action sampler. Constant timer. If you want to have each thread group pause for some amount of time between the request, use this timer. Okay, so 3.3 seconds. Under 1 seconds we have 1000 milliseconds, so 300 milliseconds simply means 0.3 seconds. Again, if you want each thread, okay, so if you want to have each thread pause, each thread within the request, so every time when the loop starts and starts hitting the request, then each thread will pause for that time period, for that constant time period before hitting the next request. Alright, descriptive names for this timer that is shown in the tree now. Thread delay, number of milliseconds to pause. Gaussian random timer. The timer pauses each thread request for a random amount of time. The timer pauses each thread request for a random amount of time, with most of the time intervals occurring near a particular value. The total delay the timer pauses each thread request for a random amount of time. Okay, this thread pauses each thread request for a random amount. Gaussian random timer gives a uniform constant timer. Constant timer gives constant pauses each request is sampler for the constant time period before starting each thread group, but random Gaussian random timer pauses each thread request for a random amount of time, with most of the time intervals occurring near a particular value. The total delay is the sum of Gaussian distributed value with mean 0.0 and standard deviation 1.0 times the deviation value is specified and the offset value. Another way to explain, in the Gaussian random timer, the variation around the constant offset has a Gaussian curve distribution. This deviation in millisecond, constant delay offset in millisecond. The total delay is the sum of Gaussian distributed value with mean 0.0 and standard deviation 1.0 times the deviation value you specify and the offset value. Another way to explain it, in Gaussian random timer, the variation around the constant offset has a Gaussian curve distribution. Name, descriptive name for this timer that is shown in the tree. Deviation in milliseconds. Now constant number of the millisecond to pause in addition to the random delay. Okay. Okay. Uniform random timer. This kind of time is straight for the random amount of time with this interval having the same probability of occurring. Constant delay offset. Sum of the random value and the uniform random timer. The timer pause is thread. So let's go through another way to explain Gaussian time or random timer. The variation around constant offset has a Gaussian curve distribution. Maximum amount random value millisecond or relation to pause in addition to the random delay. Okay. Constant throughput timer. The timer introduces variable. This timer introduces variable pauses calculated to keep data total constant throughput timer. This timer introduces variable pauses calculated to keep the total throughput in terms of samples per minute as close as possible to a given figure. Of course, the throughput will be lower if the server is not capable of handling it, or if other timers or time-consuming test element prevent it. This timer introduces variable pauses. Okay, constant throughput timer introduces variable pauses calculated to keep the total throughput in terms of samples per minute as close as possible to a given figure. Of course, the throughput will be lower if the server is not capable of handling it, or if other timers or time consuming test element prevent it. And B, although the timer is called the constant throughput timer, the throughput value does not need to be constant. It can be defined in terms of variable or function call, and the value can be changed during a test. The value can be changed in various ways, using a counter variable, okay, using a JXL3 or a groovy function to provide a changing value, using a remote bean cell server to change the JMeter property. See best practices for further details. Let's see the best practices that is being followed. All these lattice person JMeter use the correct number of threads. Way to put the cooking manager. Bean cell scripting. Sharing variable. Parameterizing test. Sharing variables between the threads and groups. Thread and thread groups. Okay. Constant throughput timer. Variable pauses. Okay. Name. Note that the throughput should not be changed too often during a test. It will take a while for a new value to take effect. Name. Descriptive name of this timer that is shown in the tree. Target throughput. Throughput we want the timer to try to generate. In samples found. So this one unit is a variable path is calculated to keep the total throughput in terms of total throughput in terms of samples per minute. Target throughput is the value that the user wants a timer to give or produce. This thread will maintain the target. Precise throughput timer. The time unit is a variable process calculated to keep the total throughput at in terms of samples per minute as close as possible to given for the timer does not generate threads, so the resulting throughput will be lower if the server is not capable of handling or if there is not enough threads or time consuming test elements prevented. Not in many cases open model group would be better choice for generating the desired load profile. Not if you alter timer configuration. Now revision per hour. One of the basic requirements is receive samples per JMeter. Let it be 60 iterations per hour. Business customers would consider understand if you report load test results with 50. So number of threads and think times. One of the most common pitfalls is the number of threads and think time in order to end up with desired output. Even though it might work, that approach results in a lot of time spent on the test runs. It might require to adjust. Precise round animals set match the throughput somehow. For instance, if your application is with a support engineer in a call center, suppose there are two engineers in the call center and the target throughput is 1 per minute. Suppose it takes 4 minutes for the engineer to read and review the web page. For that, you should get the two threads in the group and use 4 minutes of the think time. If your application is with a support engineer in a call center, there are two engineers in the call center and target throughput is 1 per minute. Suppose it takes 4 minutes for the engineer to read and review the web page. For that case, you should set two threads in a group. Use 4 minutes for the think time delays. In space of 1 per minute precise throughput time, but of course it would result in something around 2 samples per 4 minutes. And the result of such means you need more support engine in a call. Testing at low rates. For instance, if you need to inject and load at even intervals that is 60 seconds in between, then you would better use constant throughput timer. However, if you need to have randomized schedule, example to model a real user that executes reports, then precise throughput timer is your friend. When comparing outcomes of multiple load tests, it is useful to be able to repeat exactly the same test profile. For instance, if action X profit report is invoked after 5 minutes of the test start, then it would be nice to replicate that pattern for subsequent test execution. Replicating the same load pattern, it simplifies analysis of the test results. CPU percent chart. Random seed change from 0 to random enables to control the seed value that is used by the precise throughput controller. By default it initializes 0, and that means the same random seed is used for test execution. If you need to have repeatable load pattern, then change random seed. So some random variable generated by is to use non-zero seed and 0 by default and implementation limit. Now when using the multiple thread groups with the same thread throughput rates and same non-zero seed, it might result in unwanted firing the sample at the same time. Testing high rates and long test duration, precise more than necessary, and gives in memory. In most cases, it should not be a problem. However, in memory, there might be a case when all the samples should come in pairs, triples, etc. Certain cases might be solved by synchronizing timer. However, precise throughput timer has a native way to issue requests in packs. This behavior is disabled by default, and it is controlled with batched departure settings. Number of the threads in the batch thread specifies the number of the samples in the batch. Note the overall number of samples will still be in line with target throughput. Delay between threads in the batch. For instance, if set to 42 and batch size is if set to 42 and batch size is 3, then thread will depart at x plus 42 ms, x plus 84 ms. Variable load rate. Even though property values, example throughput, can be defined by expression, it is recommended to keep the value more or less the same through the test, and it takes time to recompute the new cell to add up new values. Monitoring. As next cell is generated, precise throughput and logs a message to the This is so that the cell generation took 0 seconds, and it shows absolute time 7 seconds. In the case above, the rate was set to be 1 per second, and the actual time instant became 1.2 second, 1.5 second, 3.6 second, 3.8 second, 4.7, and so on. Descriptive name for this timer that is shown in the tree. Target throughput in samples per throughput period. You want to obtain per throughput period, including all threads in group from all affected samplers. Throughput period seconds. Throughput period, for example, if throughput is set to 42 and the purpose of the sync timer is to block threads until X number of the threads have been blocked, and then they are all released at once. A sync timer can thus create large instant load at various points after the test plan. Synchronizing timer. Number of simulated user to group by 3, timer in millisecond. Number of the simultaneous user to group by. Number of thread to release at once. Setting it to 0 is equivalent to setting it to number of thread in thread group. Timer in millisecond is set to 0. Timer will wait for the number of the simultaneous. Active diamond group is highly performance support the features. Threads poses ठीक है